Hey everybody, all my onliners, look at this. Onliners, they should be able to see what's going on here. And let's get the Zoom going here. Onliners, how's the online doing? You've logged in on another account, I love that. Online, they say they're doing great. Sup, hey everybody, we got Lacey, we got Sequoia. Sequoia's tired, Tori's great. How's my in-classers doing? Nice haircut, right? It's very nice. There you go. You're doing great? Great. So the test, as I'm loading up here, because I don't need to screen share yet, so the test turned out pretty well. So the test turned out with an average, I'll make sure sound's on so I can mute any sounds. There we go. Good, because they'll come up in the video. The average of the test was like a 78. So if you got better than a 78, congratulations, great job. That's very good. But there's a lot of variation in the test. So, you know, the highest grade was, I think, a 97. So 97 was the highest. No one got 100 in our class. But I do know other classes so far, from what I've seen, one class was low 70s. I don't expect many of the classes to have very, very, very high. So if I had to guess, that the highest for the classes would be maybe in the low 80s tops. Your class has a better average? We are so far pretty good. We are so far pretty good. I can't confirm that we have the highest. We have in the past. But it'd be cool if we had the highest, right? But so far we're pretty good. Like I know some are in the low 70s. I don't know if everyone else has posted it. But I know we're like 77, 78, pretty good. Because some semesters we've had low 70s also. So I'm very proud of everyone. I'm very proud. If you made a C, that's all right. And here's how it works. Generally, and let's do this today. This is a really good thing to start off class with. You can't see my screen yet. Let me join. Can I join? All right, here we go. 823-617-5481. I should memorize this. All right, here we go. I like Tybee asking me, like, hey, Brian, don't we have this meeting? And, like, I'm dressed like this. Like, yeah, I'm supposed to go to a professional meeting today. You know, chancellors and all that stuff. I'm just going to go walk in jeans, like ripped jeans and stuff. Yeah, that's Brian Stevens. That's what you expect. It says it's recording, and the online one does not say it's recording, but we should be all right. You see this record button down here? Pretty sure we're recording. I've got the old lectures, I have to upload them. All right, let's go on and say that we're recording because this, yes, it does say recording on there, good. Always afraid, like once in a blue moon I'll forget to record. That's why I have the auto record on. Question, and then I'm gonna show some stuff. Go ahead, question.
Is the exam grade posted on Pearson?
The exam grades are only posted on my Pearson. So
okay, like date next to it is like the 5th of January.
That's when we created it. So it was like created then, yeah.
Okay,
So the exam grades are only posted to my Pearson, and yeah, it's like, wait, I didn't take it on the 5th of January, and it's like, yeah, it's confusing, isn't it? Unless we were to create it, so weird. There we go. Okay, we got everything nice. Unless we were to create it right afterwards, which I guess we could do, but it's nice and neat to have everything kind of structured. You can already see everything on my Pearson. Which here's the really great thing. Check this out. Go to where's a grade calculator. You guys see it on here? It should be on here. Did I not upload it? There's no grade calculator?
Yeah, there is online.
Is it? It's supposed to be here. Do you guys see grade calculator? I'm losing my mind today.
Mine is just like right here.
When you log in,
It's just
I'm going to bring up the chat. Sorry, chat people, I haven't had the chat easy enough for me to see.
it's just on there. Where yours says 0%.
Oh, no, we got better than that. I guess it's not uploaded right now. I will upload the grade calculator and we'll talk about it more next time because I don't have it currently uploaded. I sometimes have to do some tweaks to it. Oh, wait. We put it in a weird place. I usually put it as a tab right here. Miscellaneous stuff from UT. Check this out. Here it is. This needs to be updated a little bit. I should have. This responsibility falls on me. I should have switched this around because this is not going to be the most recent up to date. But everyone see I went to miscellaneous. I will update this, and this is pretty accurate. This will be pretty accurate. But where we have online quiz average or in-class quiz average, this needs to be ELQ percentage. Did everyone see where I went? And the clicker question average is also an ELQ percentage. So as long as you're keeping up with the ELQs, you can put in hundreds for these. And before I post this out again, I'll send this to everybody. Did everyone see I went to miscellaneous stuff and went to the grade calculator? Does that make sense? And this is going to be pretty accurate. I'm going to double check it over spring break, but this will give you an idea of what is going on. If you are keeping up, and this is the good thing, if you are keeping up with all the work and turning in the projects early. Did anyone turn in the project early last time? What'd you guys get? And so that's like 107, right? 107, what'd you get? 33.5, so like 106. 106. So everyone see, the biggest thing, I want to make this clear. Well, we're done with project 2 early right now, right? But did anyone online turn in the project early? Anyone? I think some of you guys did, right? So you guys got, and did you turn it in early last time? And what'd you get last time? 32.5, so you got over 100, right? So the big thing, and what I want to keep saying here, and if you didn't turn in the project early this time, turn it in early next time. And go to Stat Lab. Did anyone go Stat Lab online? I know we had some in-classers for the office today. I think, had you started the project when you came in? You had already started, right? But I'm trying to think if I worked with anybody. So I think some people might have went to Stat Lab. But did anyone work with me full through the project? We worked on it, right? How long do you think it took? And you came in at the start, right? Like you were there like first day. You're like, I'm here to work on it. No one was in my office. We worked on it, and you're making over hundreds on the project. So 1 hour of your time, one-on-one with me. That's the key. Come in early, but now everyone's going to do that, right? You're like, why'd you tell him, Brian? Why'd you tell him the secret? So working with me on the project means you can make 105s on the projects, not a 15. I think I showed you guys this the first day, didn't I? Sometimes sometimes semesters blur together. Like, wait, I've done this like 15 times. So you see, if you get hundreds and fives on the projects, literally you could almost make an A by making 80s on all the exams. You could make 70s on the exams, and you might be able to still pull off a B. You would make 70s on the exams and get a flat B in the class by doing all the other work. So I know we've had assignments for this already, but don't let this discourage you. You should be doing all the work you possibly can, doing all the assignments, all the ELQs. And I will say this, I did this analysis. I told them in my office today, I think, that 45% of the variation, which is R squared, 45% of the variation in your test score was explained by your work on My Pearson. Now that means there's other factors, right? If 45% of the variation is explained, that means there's things we don't understand. But it means that, do you think it is statistically significant what you do on My Pearson? Like that is significant in determining your grade? Yes, but it could be that people who just do the work or study more, there could be lurking variables, so many things to talk about. But I do believe that if you do the work on My Pearson, it reinforces the knowledge. So once again, I always tell people, if you do all the work, your test grades can be 1 lower than what you want to make in the class. So if you make 82s on the tests, then you'll make an A minus. And on the final, if you were to make basically an A, you would make an A. You see, it even shows you over here what you need to make on the final to make an A. Does that make sense? So if you were to make 82, 82, 82, and if you made a 90 on this, and I'll tell you what, if you made something like an 88 and you had a 91.63, I'll probably give it to you. There's no promises. But when you're that close, sometimes you get it. So once again, if you're making just B's on the test, what might you make in the class if you do all the other work? An A. If you have the hardest time in the world with the test and they are just not your thing, what do you still basically make in the class? What did this person make with failing all the tests? A C, which gets you through. So once again, it's always possible to make basically 1 letter grade above. The A to the B is the hardest one because it's a tighter range. But if you have someone making 65s, this person might even pull off a B minus. They pulled off a B minus and they made D's on all the tests. D's on all the tests, B minus in the class. And to make a B, they would just need a 72. And then they've made C's and D's on the test and they got a B, a straight B in the class because they did all the work. And I really think that says something. So please let this encourage you to do all the work, to when project 3 comes around, to turn it in early. And I think the more you work at the assignments, and here's the biggest thing, we've got test 2 on the way. This is my last little quick story. I had a student who freaked out. They made, I think it was like a 74 on the final, on the first test. And they were like, they were crying, and it makes me so bad when students cry. I don't know what to do. I'm like, I'm not supposed to really touch you, but I want to like touch you on the arm and be like, I'm sorry. Like, I mean, I'm a teacher, you know. I mean, like, you see someone crying, you feel so bad. You want to be like, it's all right, it's all right. So they were in tears and they were all freaking out. And they're just like, I've never made this low of a grade. I don't know what's going on. I don't know what went wrong. And we looked over the test and I was like, well, you just made little mistakes everywhere. Like, they just all added up. It was just the calamity of everything going wrong. And so I was like, I really think you're a better student. They're like, yeah, I don't even make B's. I've never made a C before on anything in college. They were like a junior, like, I've never made a C in college. You know what they made on their next test? 94. And now look at what they need to make on the final to make an A. And all that does, because think about 74 and 94 average to what? 84. They're back on track immediately. So let this be to anyone who feels like they got a bad grade on this, even if you made a 54 on this test, let's say you made a 50. You made a 50 on the test, but you're doing all the work, which is key to this class. 94 is obtainable on the test. You won't be able to make an A in the class, but you could make an A minus and you could still make a B. Frankly, if you were to just make 85 to the rest, I bet you'd still pull off a B. You pulled off a B right there. If you made a 50 on the last test, you're not sunk. You're doing all the work. So let this be, the biggest thing is to do all the work. Are there any questions about this? This is under miscellaneous stuff. I'll be kind of updating it. I'll put in, right now it doesn't say the ELQ stuff. I'll make sure everything in here is accurate. I wrote this. It's all different formulas. There's calculation stuff hidden over here. It's hidden right, should be hidden around here. I made this. I have it like, there should be things hidden in here because that's to do the calculations. Did Charlie change it? This is the one I wrote. Maybe I'm losing my mind, guys. Maybe mine was even more detailed in craziness. I don't know. But this one works, and this does it, and you can put in a hypothetical exam 3 score, and there's part of the formulas right there. And you can see all the formulas right here for everything calculating your grades. It was a fun weekend project. Any questions about this and about your grades and about the midterm? Or the first test, midterm for my classes? Questions, questions, questions? You guys want to start this class with some of the hardest questions that people get wrong on test 2? Let's do it. Let's go to hard questions here. It's time for hard questions with Brian Stevens. It's like needs an intro, like a title card drops down. It's like, like someone's pulling out their hair. So let's do it. Microsoft Word 2013 and 2017. Oh my gosh, what are we doing here? We're talking about how much we love UT before the start of the class, and now we're in 2013. I love UT. I really mean it. We're easily the best school in Tennessee. Easily. I'll even give us like North Carolina. I like Appalachian State a bit because that's the wrong one. But we got North Carolina covered, Tennessee covered, Kentucky, Ohio. We got Cincinnati beat. Yeah, we are the best. What's a better school than us? None. I agree. Okay, that was a hard question. We're done with class. Let's try a harder one. Probability, it rains. With the last class, we ended off with some probability stuff. And frankly, let's do some easy stuff first because we didn't cover these. We got right to, I think, the complement rule and the probability of the events in the set equal up to 1, right? And then we talked about the complement. We did not do the multiplication or the addition rule, correct? Well, those are actually the easy things. I want you to think about this. If I told you the probability it rains or the probability it does not rain, I want you to think about that. What must that equal up to? It either rains or does not rain. And do you hear the or word right here? Nice job online or extra credit and in class extra credit. Probability rains or does not rain. A key word right here to associate, so let's write this down, addition rule. This is, uses the word or. The two events must be disjoint. Let's talk about what happened today. And I'm talking about like when someone says, today it rained. Like it rained at some point today. But if someone says, it did not rain today, what do you generally think? You think they're talking about like it did not rain today, right? So would you agree with me, it either rains or does not rain on a day? And they're not saying it rained all day. They're saying, it rained at some point today, or there was not rain at any time today. So these events are complements of each other because one of them must occur, and we could say the probability of, like we said, the probability of rain. Oh, I keep thinking time is going tomorrow. I was going to wave to him. We can say the probability of rain is equal to 12% or 10% on a given day. That's a nice number. So what would be the probability of not rain? Exactly. Probability of not rain is 90%. Nice job, onliners. Or Mackenzie especially. So probability of rain is 10%. Probability of not rain is 90%. So as soon as we say it did not rain, do we know if it rained? Yes or no? If I say it did not rain today, do you know if it rained today? You do. Yeah. It's weird because you're like, yes, I know. You're not saying yes, it rained. You're saying, I know. And think about this. We know about grades also, but here's what's going to happen with grades. This is the complement rule right here, where we could simply say, we could do the complement right here. Check this out. I'm going to take this equation, and I'm going to mathematically solve for the probability of not rain. I'm going to take this right here, and if I subtract it from this side, I have to do what to the other side? And look at that. Do you see it? The probability of not rain is 1 minus the probability of rain. Does that mathematically make sense? Because either it will rain or not rain, that is everything. So when we look at it up here, an event plus its complement is equal to 1. How do you say the complement? You merely say, not this. Because it'll either be this or not this. We'll do some tricky stuff with that in a moment too. So rain or not rain must happen. So when we look at the probability of it not raining, it's everything but it raining today, which is 90%. It'd be 1 minus 10 equals 90. Mathematically makes sense to everybody? That's the complement. But what about, let's change it up right here, because we have the addition rule. This was kind of a review of the complement. Complement is everything but that event. But we have the addition rule right here, which works with the complement, because can an event and its complement happen at the same time? So can it, like today as a whole, not rain? Is that possible? Could it not rain today? Could it? Well, it didn't, but it could not rain today. Could it rain today? It could. Could it, and this is like as a whole, when we talk about the day, say, oh, yesterday it did not rain. Yesterday it rained. And someone will be like, well, what do you mean? It rained? Well, then it rained yesterday. And to make it more clear, let's look at an example here where you talk about what you get in this class. Fun times, right? Let's increase that, right? 25% of the class gets A's. 20% gets B's. 30% gets C's. What's this put us at now? Right? 75, right? 20% get D's and 5% get F. Answer me this. Can somebody in this class, in this one session of the class, like let's say for all students who get a grade, can a student in the class make an A or a B? Could someone make an A or a B in this class? Could a student make an A and a B in this one class for their whole grade? No. What it means for events to be disjoint, also known as mutually exclusive, so let's put that in the note right here. Disjoint, i.e., and I see people doing this during the test. If two events are disjoint, i.e. mutually exclusive, it means when one happens, what about the other one? It cannot happen. Do you see that? As soon as I say, I made an A in the class, you'd be like, well, that's great. Did you make a B? Like, no, I made an A. Well, did you make a B though? I need to know. No, I already answered that question. Because if events are disjoint, One happening tells you what about the other ones? Those didn't happen. So think about this. What would be the probability someone makes an A, B, C, D, or F in the class if they get a grade? So they get a grade, what is it? 100%. That's actually the set of all events. What did we just do to those probabilities? We added them up. We can easily add up disjoint events. So we had A or B. What's the probability of A or B? What is it? 45%. So you'd say the probability I make an A or B if my grade is randomly assigned is 45%. Nice job, Tatiana. Extra credit right there too. So probability of making an A or a B is 45%. Probability of making A, B, or C is 75%. What is the probability I do not make an A, B, or C? 25%. Do you see how we can talk about the complement of a whole bunch of things? So we'd say, and I could say, what's the complement? I'm saying it. What is the probability I do not make an A in the class? 75%. That is the complement of making an A. What is the probability I do not make a B in the class? 80%. Do you notice how the complement is everything but that event? Here's a trick question on the complement that catches a lot of people. I don't know if I used it last time. My brother, he's going to have 4 kids, and he's already got 1 boy. So let's look at, he's got 10 kids. I'm going to jinx him here. I don't know how many kids I want. Hey, Darren, I was talking about you in class today about your kids. My nephew's name is Tolliver Dean Debanim Stevens. TDS. I guess he's got the DS. My brother's Darren Stevens, like the witch. Tolliver Dean. I like Dean. You think he's going to go by Dean when he's older? Or Tolliver? Oh, Tolliver. It's an Irish name. We're not even Irish. I don't know what's going on. If they have a second kid, I don't know what they're going to name the second kid. Do what? I don't even know. I like Tolly. Tolliver's the new thing. I don't know. So what is the complement? Ooh, you've already done it. Extra credit there. Online and did I use this last time? Dang it. Bummer. No cursing today. I cleaned up my potty mouth. No HE double hockey sticks words for me. What about the complement of raining every day this week? Oh, I'm gonna trick you guys. Wait. Careful. You guys are maybe saying it. I think people are saying it. You're basically saying it. Explain to me in further. I think people are using the not. I'm going to make it so you can't say not. You can't say not. First person gets 5 extra credit who does not use the word not. Oh, Gabrielle's got a 5 timeser. Gabrielle's right. And I did this with you guys last time, I think, too. Yes, it is that. And Gabrielle's basically got it. Gabrielle said, correct. That's right. In class, they said raining less than 7 days a week. I did this with you guys last time too, right? Let's look at it again. What could happen when it rains? We got the probability of it raining being 10%. Does that make sense? So the probability it rains is 10%. So let's look at this right here. We have how many days it could rain during the week. So it could rain 7 days out of the week. Does that make sense? What is the complement of raining? What is the complement of raining 7 days out of the week? Does that make sense? Well, so the event is raining every day in the week. What is the complement or everything else that could happen? It rains less than 7 days. Does that make sense? I think people get this example. These are the tricky ones. These are the ones that people just get to on the test like, I have no idea how to do it. I'm just stuck. Let's use these numbers up here, and let's talk about the multiplication rule, because that's what's going to help us do this. So the multiplication rule Uses the word and. Let me capitalize that. I think I have a chapter review for this up, and it's really good. It's a really good, concise review. But I mean, more examples help. So I highly suggest watching the chapter review maybe this weekend of this. Like this second test, I think is more conquerable than the first test because it generally has less material on it. So you can really knock it out of the park on the second test. The third test is very stat-like. We get back, we have a week, and I think it's the Tuesday after. I think so. It's on Wednesday, so it's the Wednesday. I knew it was around. Man, that thing changed around so much at the start of the semester. I literally sent you guys, they were like, this is when we think it'll be. And so I sent you guys that, and then the next day I got an email. Don't send that to your students. I was like, oh, no. I was like, no. Just sent it out. I'm trying to be on top of things and keep you guys informed. So I think I even changed the announcement. I'll send a lot of announcements about it. We'll double check. We'll know it's on Wednesday, I believe. The reason why things have to change is because since we do section-wide tests, we have to get enough rooms booked on campus for everybody. So that's a feat in and of itself to have all the rooms booked up properly. So what about this multiplication rule? Let's say I take random students. And I'm like, okay, well, I'm just going to select some random students from my classroom. Like I've got a whole bunch of students. Let's say I got 1,000 students. And I know generally the grades for my students are, 25% are A students, 20% are B students, 30% are C students, 20% are D, and da-da-da-da-da. If I select a student at random, will that student influence another student to be an A, B, C, D, F if I select another student? Like imagine, I'm gonna pick a student at random, bink, and then I select another student, bink. Did she influence you in any way to be a certain type of student when I picked you? No. So would you say the grade of one student is what to the grade of another student? Independent. Does that make sense? So the grade of one student is independent to the grade of another student. So this is what independence is. It's when we talk about something like if let's say, here we'll use an example like this. If you buy an iPad, the probability it will have a defect is 0.02. 2% of iPads have defects. So if you have a defective iPad, you're going to have to send it back, right? And that would be a bummer. What is the probability you buy an iPad and it's defective, and then you buy another iPad and it's defective? Like you get 2 defective iPads in a row. What's the probability of that? Look at the rules. Say it again. Is that right? I think you're right. No, that's right. So it's 2% of 2%, which is a very small amount. Does that make sense what I did right there? So, I mean, wouldn't you think, imagine this, let's just think about it. So you haven't bought, I want to make this clear. The gambler's fallacy we talked about would be if you bought an iPad and it was defective and they said, well, what's the chances I get another defective one? At that point, what are the chances you get another defective one? If you go back to the store and buy another one, what's the chances after you buy your first iPad? 2%. Gambler's fallacy or the law of averages would state, which I often call gambler's fallacy. It's the way I first learned it way back when, 15, 16 years ago. The gambler's fallacy states that law of averages, I'll call it. The law of averages states that, I just got a bad iPad. It's less likely I'll get a bad iPad again. But no, what's the probability if these events are independent? Apple just sends them out, right? Does that make sense? Are they sending all the bad iPads to one place? No. I mean, it might have a dead pixel, a bad connection port at the bottom. They're just putting them in boxes. They're shipping them all out. They're also testing them. They go through testing before they get sent out. So Apple's going to, send them all out. And unless you say one box could be damaged, let's just avoid that. Shipping could have caused that whole place to have damaged iPads. Let's say, in general, iPads just have random defects, and 2% of them have a random defect that would cause it to be what we would call defective. It won't charge, there's dead pixels, something like that, right? So with that in mind, if you go to the store and buy one iPad what is the probability to be defective? And let's say you do get a defective iPad and you return it and you go buy another one, what's the probability that one will be defective? But if you were to currently own no iPads, what is the probability right now if you go to buy iPads that you would get 2 defective ones in a row? Does that make sense? And doesn't that seem very unlikely? Only 2% of iPads are defective. So it would seem unlikely that you would get a defective iPad. What word would I say next? Wait, so you would get a defective iPad and then get another defective iPad. Do you see how the N word comes into play? It's connecting it right there. Nice job, Gabrielle. Nice job. So what's the probability of getting one defective iPad and then getting another defective iPad? We can even look at this for things like with it raining. Like I could say, and I realize I switched to this because rain might be like, oh, if it rains today, it's more likely to rain tomorrow. You could make an argument that rain is not independent. Does that make sense? But let's say each day of rain is independent. Let's assume rain is independent because we have to do that for these examples. So if rain is independent, if it rains today and tomorrow, do you see what I'm doing right here? I could type it right now. I now have written the probability that it what? There's 4 and there's 3. Rains every day of the week, because I would read this in a sentence. I would say it rained on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And I would say in between all those. It rained on this day and 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 this day. Doesn't that seem highly unlikely? It does. That it would rain every day of the week. Now, as I keep saying, rain is not a perfect example because rain is not completely independent. That argument could be made. That's why I switched to shipments of iPads and them being defective. Because if you go to Walmart, and I mean, what is the chances? I mean, they're going to think you're scamming them, right? If you go and get 3 defective iPads in a row, like you keep going back to Walmart after everything. They're like, "What are you doing?" And you're like, "Really? I swear." You know, like I swear, I'm getting defective iPads constantly. And they're like, "No, we know you. You're the person who just uses the iPad for a week and then wants to return it to get a brand new one." And I just go, "Yeah." It would be very, very unlikely that you'd get 3 defective iPads in a row. Do what? I do? It's even more unlikely. Does that make sense? What's the probability you would not get 3 defective iPads in a row? Actually, that would be the probability that you would get 3 good iPads. So let's look at this. Let's look at this. This is where people get tricked. This equation right here is the probability you buy 3 iPads and they're all good. So the question was, what is the probability that if you buy 3 iPads that they will not all be defective? Bingo. Mackenzie got it. Careful. Well, think. Wait. Remember I said they'll not all be defective. So Mackenzie caught up on it. This is the tricky ones that catch people. Let's look at... What could happen when you go and buy iPads? You got it. Because think about this. What did we just solve for? We solved for the probability that all 3 are defective. What do we want to see? The probability that not all 3 are defective. Would you agree one of these things must occur? If you buy 3 iPads, either all 3 will be defective, 2 will be defective, 1 will be defective, or 0 to be defective. So what is the probability all 3 will be defective? Right there. So what is the probability not all 3 will be defective? Everything but that event. Does that make sense? That's the tricky stuff. Nice job, Mackenzie. 5 times extra credit. Great answer. Yes, and I've got that on the screen right there. So, and that's the really tricky stuff that just wrecks people on the test. They're like, I have no clue how to do this. Write the number line. I think that's the easiest. Do you see what the number line means? You have to imagine what it is. You have to pretend. You go to the store, and what happens in this scenario right here? You get no bad iPads. We could write that out right here. Did I highlight still? The probability of no bad iPads is simply that. So the probability, and here, let me put, watch this. Oh, this would be such a hard test question. So the probability of of all bad iPads is this. the probability of no bad iPads is this. So, and I mean, you can probably tell it's very likely if you buy 3 iPads that none of them will be bad. Does that make sense? And then we could do some math and figure out these. I know the equations to do it. It's the binomial stuff. But even, I don't want to, it goes above and beyond for this class. Might as well show. Might make more sense. Someone might have a bell ding in their head. We're buying 3 iPads. The probability it is bad is 0.02. Oops. And so here we are. Do you see that right there? So now this is the probability that none of them are bad. And look at what we have. 0.941192. 0.94119, and it annotated the 2. The probability 1 is bad is this. And if we say the probability all 3 are bad, it rounds it to that. Yeah, because it's 0.008, and it rounds it to that right there. So this is actually finding it. And if we want to look at the probability that 2 or less are bad, this will actually find that for us, which is, we figured out earlier, it's basically 99.99999% that we'll have at least one good iPad. Wouldn't we describe this right here that we have at least one good iPad? Because it's extremely unlikely they would all be bad. Does that make sense? It's more likely that one would be good, which is described by the probability they're all bad is extremely unlikely. The probability that at least one is good is very probable. That's got it. That's you guys want to do another example of this? Let's do another one. So let's use my, and do you see what we're doing with the multiplication rule right here? The multiplication rule is being used to show when we have independent events, we can multiply them together. So let's say, so here's my fear. I need an A student. I need an A student to help out with what I'm doing. So I'm gonna pull up my roster and I'm gonna start emailing out, and I'm gonna email 5 students because, and I have to do it at random. The university says I can't pick students. I have to pick students at random. I'm gonna pick 5 students, and I need at least one of them to be an A student. See if you can work this problem. See if you get the answer. Such a good fake test question here. I need one of my students. I'm not gonna do it. This is the way I do it. This is my way of doing it. I really need one of them to be A students. I need one A student. And we'll say everyone responds. I'm giving them $100 to respond to this. So they respond. Oh, everyone responds. So you don't have to say will they respond. But do you see I'm selecting students at random? Does that make sense? And then what am I requesting? That I get?
Just one or at least?
I need at least one A student. Because for some reason that A student is gonna get the work done properly. I need at least one A student. Because I'm oh no, if I get all F students, that'd be horrible. But if I have at least one A student, I'll be fine. So what is the probability I get at least one A student? First person who gets it, I give you 10 times extra credit to. Maybe. Well, I got a lot of answers coming in right now. What'd you say? Nope. I'm emailing 5 students. I want to get at least one A student. 5 students, at least one A student. I'm emailing 5. You can type the answers in online. I'll answer in here in a moment. I'm giving it 10 times extra credit first person who gets it. Let me solve it in my head. That's the first answer I've found that might be right. The first answer I've heard. I'm gonna solve it in my head real quick. Give me a half second. That's close, but I think that's wrong. Give me a half second. Okay, I know the math. I'm just solving the equation, which is too hard. The power. Okay, I can get close enough. Yeah, I know what it should be close to now. I've got a range for answers. Sequoia might be right. Sequoia's got something that I think could be right. All right, no worries. Any other guesses? That sounds right, and that's just, you're not Sequoia, right? Okay, you and Sequoia have the same thing. Sounds about right. But did you use 0.25?
I did 0.25 times 0.25. You get 1 minus 0.75.
I'm going to give Sequoia and you have 5 times, and then you did it the right way. Did you do it that way?
Is that what it is? 1 minus 0.75.
That's right. Let's break it down. Let's see what happened. Good job to everyone who thought it through. I just wanted to give a little time. But so let's see what doing. So I want you to think about what you say here when you say, let's read what it is. 1 minus 0.25 to the 5th power. Careful, because this is everything but. How is this event described right here? 0.25 to the 5th power is what? That's everything but. Well, so wait, what is this thing I have highlighted right now? What is that? What does that mean? All of them got A's. Does that make sense? So this would be the probability of what? I think Sequoia's basically got it. There is what? I'll say it, but I want to hear you guys think and say it. This is the big crunchy things. I want to make this clear. This right here, does everyone see this? It stands for this, which means everybody got an A. Yes, Sequoia right there. Less than 5 students being A students. So this right here is everything but this event. Does that make sense? So this mathematical right here, do you see this right here? I'm going to highlight the other part of it. This and this correspond to the same thing. Does that make sense? This is the probability they are all A students as what I have here for my notation for it. Then when we do 1 minus, we get the complement of that event. Does that make sense? So now instead of they're all A students, say it to me without the not word. Instead of they're all A students, there's at least 1 non-A student. Does that make sense? Because there could be 4, 3, 2, 1, or 0 non-A students. Does that make sense? So that's what that equals. But now let's flip it to that. Just tell me briefly what this right here is. Tell me what 0.75 is. The probability they are what? Probability they did not get an A. And if we have this right here, this means all 5 of them did not get A's. So now we have this right here where we have the probability 0 of them got A's. Does that make sense? What I have highlighted in both spots is 0 students got A's. But do we want to see 0 students getting A's? We want the complement of that, which is the probability at least 1 made an A. And I really think if you're watching along here, does this make sense as I highlight them and what they mean? This is the way to break it down and why I'm covering these super hard questions that we usually throw one of them at you. They're usually worth maybe 3 to 6 points. And it could be the difference between a letter grade right here. But if you know how to work it, you need to talk about it like it's a sentence. Just tell me what this means again right here, what this one thing means. That is the probability a student did not get an A. This is the probability that all 5 students did not get A's, so we have 0 A's. Then if I want to find the other side of it, I simply take the complement of that. Because now I have everything but there were no A's with the 5 students, which means there was at least 1 A, because I'm saying everything but all non-A's. Does that make sense? At least 1 student made an A. If you mathematically solve this, which I think you basically figured out, but this was as hard, I'm trying to make as hard as a question I can possibly make up. So you're following along with these examples. I can mix it up. I just thought that was really hard because we have a lot going on right here. Truthfully, on the test, I would think only 20-25% of students would get that. Use my number line trick and try to talk about what this means. Try to think about like, oh, I want to see at least 1 student getting an A. So what do you not want to see? If you want to see at least 1 getting an A, you don't want to see that. You don't want to see that No one got an A. So then it's the complement of no one getting an A. So you just have to figure out then how to write no one got an A, which is all 5 people did not get an A. Questions? Good. These are the hardest things I can come up with. We've got a lot of time. I might start breaking into the next lecture today. I'm 50-50 on what to do. Maybe we'll end a little bit early today. You guys want to do a little more probability and end a tiny bit early? I will hold class next time, but it will be recorded. Does that make sense? So we will hold class next time. It will be recorded. And so no worries. I will hold class. That's what you guys want. So we'll end a little bit early today, probably like 15 minutes at like 6:05. Let's do a few more examples. That way we can have a really, here's my fear. The next chapter is probably the hardest. Probably the hardest. It's a very formula. It really starts to be where we start to go away from like things you may have done before. It's sampling distributions. But it's not that crazy. It's not that bad. It's just that either you know it or you don't. And the really great thing is when you get to the test, if you know it, it's just like every single one of those questions. All you do for the next chapter, I'll do a few more. We'll do like 2 or 3 more probability problems. Let's go to the normal. Here's how the next chapter works. So I'm just gonna do a quick example from the next chapter to not scare you because it's like, whoa, what are you gonna teach us next? This is one thing we'll do in the next chapter is we have a balcony. This is an example we use. The balcony has, let's see. What we know is if the average weight of 25 people on the balcony is more than 200 pounds a person, the balcony will fail, or like we're over the regulation. So this is actually a balcony that we ensure that no more than 20 people go on. It's like your home balcony, and the constructor told you, you cannot put more than 20 people on this balcony, and the average weight cannot be more than 200 pounds. So that'll be a problem. So now what we have here is we want to say that the average American has a weight of, making this work out, 180 pounds with a standard deviation of 50. A lot of differences in weights because weights is a highly skewed distribution. There's some things I'm skipping over this, but all of a sudden, what do you see? Normally distributed with a mean of 180 and a standard deviation of 50. Can you draw that? If I give you a normal curve. But think about what we're saying here. You can now put 20, I meant to say 25 if I didn't. You can put 25 people on the balcony, and the weights of these people cannot be more than 200 on average. We no longer have the distribution of a single observation. We have the distribution of a mean. And the original standard deviation, this is really the trick to it. That I want to say this today where people get messed up. I'm not teaching the whole lecture right now. This is really just a snippet. Like one of the biggest things people mess up. The new standard deviation. That's the new standard deviation. So when we have one person, what would we expect one person to weigh on average? One American. On average, one American would probably weigh what? 180. Now, if you have 50 Americans and you took the average of their weight, what would you expect the average weight for 50 Americans to be? If you averaged up their weights, like what you do is you go to them and you average their weights. Does that make sense? You say, okay, you weigh this, we add them all together, then we average them. So if we were to take the average weights for 50 Americans, now tell me this much. It would probably be what if you were to average 50 Americans' weights? It'd probably be 180. Because if one American weighs 180 on average, then you average together a whole bunch of Americans. Well, some are going to weigh more, some are going to weigh less, and it'd probably average out. That's why the mean does not change. But what we see here is what changes? The standard deviation. Because if you get a whole bunch of Americans together, won't some be high and some be low, and it's going to average out a lot more? What if you got 50 random Americans together and the average weight was 300? Wouldn't that seem really weird? Like, whoa, we got 50 random Americans, the average weight was 300. that probably wasn't random. But if you got one American and they weighed 300, would you be like, whoa, that can't be random? You'd be like, well, that's really high, but there's a lot of variation with one individual. So what we actually see here is a distribution of what the mean might be. If you invite 25 random friends on your balcony, then the distribution of the mean will be tighter by a factor of the square root of what? Square root of the sample size, square root of n. And you know what you do with this? All you do is you go back in here and you answer it this way. What's the z-score? It's off the scale, but what's the z-score for this? The z-score for 200 is now what? It's what's the z-score, do you? Just count it, wait, careful. It's greater than 3, which, it's what?
Oh, I was doing so,
but this is no longer for us. This is, and here's the thing, this is why I'm doing this right now. So unless, Gabrielle caught me. I made a mistake. I looked at what Gabrielle said. I don't know how to math. Gabrielle, this is gonna cause problems. Now, what is the z-score? Gabrielle, 10 times extra credit, caught me in a mistake. I messed it up. Oh no. I like what Mackenzie said up there. I didn't see that yet. I'm so sorry for that room, everyone. I hope we aren't using it again. But what is the z-score for the failure of our balcony, which is 200 pounds? What is the z-score? It's what? Careful. No, what's the z-score? They said Montana got online, Montana extra credit. 2. So if the empirical rule, what percent of the time, if we have 200 people on our balcony, would our balcony fail? 68, 95. What percent of the time would we expect our balcony to fail if we have 25 random friends on the balcony? 2.5, right? Very close to. I mean, this is exact. Empirical rule is an estimation. So basically 2.5%. Does everyone see what we're doing here? Now, I haven't taught you this full chapter, but I want to explain what people get wrong, and then we're going to use this for a probability example before finishing up. The reason people don't get this chapter right is they're like, oh, I was told for this problem that the mean and the standard deviation were 180 and 50, and then they just use that. No. And sometimes we trick you because we use a chapter, we see if you know the difference between this chapter and the last one. If we're doing what we would expect for 50 people, or 25, excuse me, if we're doing what we would expect for 25 people, would there be more or less variation? And look at this. What we expect for 25 people has more or less variation. Has less. Does that make sense? I just made that up. I made up 50. You'd have to have all the data. If you had the data, you could easily calculate it. So that was just me making up a standard deviation. Sorry. But does it make sense that if we talk about on average, if we average a bunch of people together, would there be more or less variation? If you average people together. Imagine this. If I were to take the test scores of my students from you guys, and if I were to take, and we had a 78 average with a standard deviation of 10, the top 16% of the class would have grades of what and above? Which top 16% would have grades of what and above? So we were talking, yes, we're doing an average of 25 people. That's exactly it, Sequoia. This is now, if you were, and I want you to envision this is setting the stage for next lecture, and I'm going to do a probability thing with this too in a second. What we have, Sequoia saw the previous example, in this right here, you have to imagine that I have invited 25 friends out on my balcony. And now I'm talking about the average weight for those 25 people. Like if I were to average out all their weights, what would I expect the average weight to be? Does that make sense? I'm going to invite 25 random friends onto my balcony. Does that make sense? So do you think it's likely that it'd be up towards 300? Like this one right here, 280 is only 2 standard deviations, right? I mean, you could have someone who weighs 280. You could have someone who weighs 80 pounds. That's 2 standard deviations below. But when we invite 25 random friends, do you think the average of those friends would have a lot more variation in it or less variation? The average, you take all their weights and average them up. It would have less. Does that make sense? And now with the grade example, if I go to Stat 201, let's say this is for all Stat 201, and the average across all sections was a 78 with a standard deviation of 10. But instead now, I were to talk to 100 students, how much tighter does it get? Do you see it? The new distribution would have a mean of the same. Because if I talk to 100 students, what would I expect the average of 100 students to be? And now, do you think, wouldn't it be weird if I talked to 100 students and they had like an 88 average? I'd be like, wait, you told me the average was a 78. I talked to 100 students and they had an average of an 88. Wouldn't that be weird? Because the new distribution of the mean is tighter by the sample size. Does this make sense? So it's going to get tighter by a factor of the square root of n. So the new distribution of the mean would have 78 as its mean, and it would be tighter, and it would only have a standard deviation of 1. So this is what we're doing right here, and we're going to go a lot more into this and do the full lecture step by step next time. But this is where people have no idea because they don't use these formulas. Chapter 15 goes over this. We have a lot of time, and I'm going to go start from scratch with it next time. I just wanted to show you it because people just, when they get back their test, they're like, wait, I did this. You said this was the mean and standard deviation. But we said, no. But the thing was, we wanted the distribution of the mean for 25 friends, not a single observation for one friend. This is for one friend. Does that make sense? This is the distribution when you invite 25 friends on your balcony. Can you repeat how you interpreted that one more time? You said the new distribution of the mean is tighter because the new distribution of the mean is tighter because we're averaging together the weights of 25 people. And if those people are selected at random, so when you look at the distribution right here, if we had this distribution right here, and I select people at random, I'm just typing in a number, I could get someone here, or 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 here. Do you see what I'd get people all over if I selected at random, right? And then what would they all do? They would all average out towards the center. So the new distribution of what could happen when I invite 25 friends on my balcony has less variation because I'm going to average out things together. It's like if I talk to 100 students, it'd be weird if they all got A's. I'd be like, what? But if you talk to one student, let's look at one student, could one student have gotten an A on the test? Just one. Does this make sense? Do you see where a 90 is? Does it look like one student could get an A on the test? Does that make sense? That's chapter 5 again. Sorry, crazy things online. So one student could get an A, right? But what about I talk to 100 students? Then I take the original standard deviation and divide it by what? The square root of 100 to now would get what would happen if I talk to 100 random students. Do you understand that? If I talk to 100 random students, do you think it'd be likely that they would all have A's? Or the average of their grades would be A's? It's basically impossible. If the average of the test was a 78 and the standard deviation was 10, if I talk to 100 students, it would be 10 divided by the square root of 100, which is 10 divided by 10, which is 1. You would see something really close to 78 at that point. And to bring it back to our balcony example and to do one last probability problem here, let's do one last one. We have that our balcony can handle 180 pounds and standard deviation of 10. Our balcony will fail 2% of the time, let's say. Let's just call it 2%. 2% of the time when we invite random friends on our balcony. Well, I only plan to have 10 parties on the balcony. I only plan to have 10 parties on the balcony. Do you see where this is going? What is the probability the balcony fails? Probability the balcony fails is, we just saw it, 2%. So now, so I'm just using 2 as an abbreviation for it. Does that make sense? What do we not want to see? And I will repair it immediately if it breaks. So it'll be repaired if it breaks, and it'll be repaired the same exact way. What do we not want to see? Here's a hint. They might set it online. I think Sequoia. Think about what you have. Sequoia's close, but Sequoia has the probability my balcony breaks every time, which would be really bad. Sequoia wrote out, and I want you to think about this as a sentence. This is the probability my balcony breaks every party. Does that make sense? The probability it breaks at one party with 25 friends on it is 2%. The probability it breaks at every party is that. What do I not want to see? Or what do I want to see? You can tell me that. You don't have any ideas? Say it loud. You got it. So what numbers should I shade in? What was said was I do not want it to fail at all. So what do I want to see? I want to see that it never fails. I don't want to see that it fails at all. So how would we find the probability my balcony fails at least once? So, and Gabrielle, you have, and so what Gabrielle has written, I'm going to read it off here, because these are, like I say, these are the killer ones. That's why we spent today doing this, because these are the ones that kill. Right here, this is the probability. How would I shade this in? The number line represents how many times my balcony fails. That is what we have shaded in. I'm going to put an X right here yet. We haven't figured that one out yet. This right here is the probability of everything but it fails all 10 times. Do you see this is the probability of it failing? This is it failing all 10 times. And then if you do 1 minus it failing all 10 times is the probability of it not failing all 10 times. How do we describe this event? Just talk to me about it. What happened? At my first party, what happened with the balcony? At the first party, the balcony, it didn't break. Nice job, Gabrielle. It did not break. And then at the next party, it what? It didn't break again. And this means my balcony how many times did it break with my 10 parties? 0 times. So what do I do to this? Does that make sense? Does that make sense why I wrote that? That is the yellow event. What is the red event? Does that make sense? Because when we describe this, my balcony did not break is this. My balcony did not break at all 10 parties because we're talking about what happened with our 10 parties. There were 0 breaks of my balcony. The probability of it not breaking is this, and it did not break at all 10 parties. So now, if we were to look at, what's the probability I'm going to get sued because it breaks at one of my parties? It is this, because it's everything but my balcony not breaking at all 10 parties. Bingo. If you say the probability of everything but 0, it's a probability of at least 1. That's exactly it. I think these are really good examples right here. These are the toughest things I can come up with. Tiny bit early today, but yes. What'd you guys think? These are as hard as I can come up with. So it not breaking is, so Sequoia, it's explicitly that probability right here. The probability at one party my balcony does not break is this. The probability my balcony does not break at all 10 parties is this. So then the probability it breaks at least one party is the complement of the 0. This probability right here that I'm hovering over right there is the yellow one. So if we do 1 minus that, we get the opposite sign. What would this tell me about this event right here? Just tell me what happened if this occurs. Tell me what would happen if this occurred. At one of the 10 parties, my balcony broke. Does that make sense? Nice job online. So at one of the 10 parties, my balcony broke. Because think, it'll either break at none of the parties or it could break at least once. And we're not saying it broke 3 and 4 times. What we're saying is I'm going to throw 10 parties and it could be that my balcony breaks 3 times. I'm going to repair it each time in the same fashion. Does that make sense? But it could be my balcony breaks 3 times or it could break 4 times. Do you hear the or there? Do you see you can add these up? That's why you can subtract them. Because if I throw 10 parties, can my balcony break 0 times and 3 times? No. These are what of each other? Each one of these are what? They are disjoint. They are very disjoint. They are actually very dependent. Here's one last thing I want to say. This is the last thing. They are disjoint, and disjoint events are actually dependent. Because if I tell you I made an A, does me making an A depend on me making a B? Like to make an A on the class, does it depend on you making a B in the class? Does it? In other words, if I tell you I made a B, do you know if I made an A? You do. So disjoint events are dependent or independent. They're very dependent. They are very dependent. Because it's like if one happens, the other can't happen. So it depends on the other happening. Like, oh, if this happens, the other can't. Because if my balcony breaks 0 times, it can't break 1 time because it's disjoint from it. If this happens, this can't happen. That's why we can do the adding and subtracting here, because you can just say it'll either break 0 times or it'll break 1 or more times. And what would all this add up to? When I say it'll break 0 times or 1 or more times, what does that equal? Rule number 2, what do you say? It adds up to 1, because one of those must occur. And did you hear me use the or rule right there for disjoint events? It'll break 0 or 1 or more times. And then you see the multiplication rule right here. When we say what's the probability it breaks 0 times, well, we would describe that as it did not break at the first party, and it did not break at the second party, and it did not break at the third party, and it did not break at the fourth, yada, 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 yada. Do you see how we're combining everything in here to get it all done? That's got it, everybody. Well, we're ending just like 7 minutes early. Email me questions if you have them. I did that last little bit to kind of pad the class. I wanted to make sure we had enough. But I think we did a really good review of some of the hardest stuff. We maybe only covered probably 7-8 points on the test. But hey, if we did 7-8 points on the test every class, that'd get all the points. But these are some of the harder questions. Do not let them crush you. Like, if you do a few of them, you learn them. Question. This would be the probability that it worked at least once, or that it did not break at least once. Because it's everything but the balcony broke every time. This would be the probability it did not fail at least once. Because it failed every time. So it did not fail at least once. Great job, everyone. Great job. Good stuff. We will have class on Thursday. No one shows up, it's okay. Watch the Thursday lecture if you don't show up, because I'm going to go over the material and then we're going to do a review of it on Tuesday. So Thursday's lecture is one of the harder ones. That's why I gave a little preface today, but you'll learn it on Thursday and you'll smooth it over on Tuesday. Maybe try some of the assignment over break. And I want you guys to ask questions. I want to make it clear, because chapter 15 is where people lose the points. You guys are good to go. 5 minutes early. Usually we get out right on time. I'm sorry I wasted yours. You're welcome. Great job. Great job today. Sure. Yeah.
Okay, so
I'm still your online people. That's everything but all the cars don't need repair. So when we go ahead and write a little number line down below. And how many cars are there? There's 2 cars. So write 0 and 1 and 2. And then we have that the probability that at least 1 car will need repair. So underline 1 and 2. And then I do a line. You can do it. That's okay. And then I do like a line going across. Yeah, just under the bottom of it. And then put an x over 0. Now, what is going to be easier to solve for? 1 and 2, or 0? 0. So that would be the probability that 0 cars need repair. So we have up here. So we have the probability it needs repair once or twice. So this is, let's see here. The probability that neither will need repair. Oh, and then, yeah, there it is.
So if you solve for this and then all you do is minus 1 minus
Yeah.
that.
So you can see it right here right now, right? Because either 0 will need repair or 1 or more will need repair. So at least 1 will need repair. Yeah, and I like the number line thing. The reason I asked you, you're like, wait, I've never seen you do it that way. Since the onliners can't see me, when I used to do this in class, I would draw it out with lines like that, and I would X over it. But since they can't see it, I would draw the number line. I'm always like, draw it, and then X over it. So that's the way I do it when I teach it that way. Yeah, all of these are disjoint, as in, it is. I know it's in, so, well, think about this. Each of these have a probability, as in, the balcony will break 0 times in 10 parties, or it'll break 1 time in 10 parties, or it'll break 2 times. And what we have here is the binomial distribution. Let's go back to that. And there's our 2%. We're going to throw 10 parties. And here's the probability it breaks 0 times. Here's the probability it breaks 1 time, or 2 times, or 3 times. And we could actually figure out, as we did, the probability it breaks 0 times is 0.98 to the 10th power. Easier to do it this way. 0.98 raised to the 10th is equal to this right here. So that's the probability it breaks 0 times. And you can see that visually right here. Does that make sense? So then if we want that it breaks at least 1 time, it's the complement of that. So as you can see, there is the probability it breaks 0 times. The complement of that is that it breaks 1 or more times. But do you see, one of these things is just, here's the probability it breaks exactly 2 times. Because would you agree, my balcony will either, if I throw 10 parties, and you say, what happened with your 10 parties? And I say, it broke 5 times, which is highly unlikely. Would it have broken, and this isn't exact, would it have broken exactly 3 times? Can, with 10 parties, my balcony break exactly 5 times and exactly 3 times? No. So if one occurs making the other not occur, the events are what of each other? So if I tell you, you're like, oh, like I was so worried about your balcony, and I say, oh, it broke exactly once. I've actually just answered the question about the other ones occurring. If I tell you it broke exactly once, it broke 1 time out of the 10 parties, and I had to fix it. So now, think about this. Do you know if my balcony broke 0 times? Do you know if it broke 2 times? You can answer all the other questions about my balcony. You wouldn't say, well, did it break 10 times? I'd say, no, it broke exactly once. It broke 1 time. Well, did it break 4 times? No, it broke 1 time. Because with these events, they are what of each other? Since I've told you it broke 1 time and you're saying it did not break 4 times, you know that instantaneously. They're disjoint. No, because would my balcony breaking 0 times depend on it breaking 1 time? Like, you see, yeah, and where things are dependent is if you know the answer to one, it tells you something about the answer to another. So I hopefully made that clear enough in class. Anyone watching the video is still seeing this. When things are dependent, if you know the event of one, like if I tell you, like the probability of getting in a crash going home. It's fun stuff to talk about. If it snows, would that increase the probability of getting into a crash? Yes. So that would not be good to multiply together, because if it snows, the probability of crashing goes up. So then your probability of crashing is dependent. It's not independent of the snow. Does that make sense? But what about the probability of getting into a crash and the probability your sports team wins tonight?
It's independent, like each party, like each event is independent.
Oh.
Equal chance.
Yeah, each. Well, yeah, that's the thing. When we multiply them together, we're actually using the rule of independence. So each party is independent of the previous party, or assumed to be, that the failure rate stays the same. that I'm going to throw a party, and it will really only fail if it reaches that limit. Like, it's not going to get wear and tear. We're going to say it's just going to have a 2%, like the probability that my friends exceed the limit. Or you could just say, what's the probability we exceed the limit? Like, you don't even have to say it fails. Like, what's the probability I'll be putting my friends at risk? And with this in mind, the probability I'd put my friends at risk at least one party would be around 18% if I throw 10 parties with this balcony, with 25 people on the balcony. Sure. Disjoint explicitly means if you know the answer to A, if A occurs, B cannot occur. Independent means if you know A occurred, it tells you nothing about B. So think about it. If events are disjoint, let's say A occurs. Did B occur? If A and B are disjoint, if A occurs, did B occur? No, you know B did not occur. So now the rule of independence is if you know A occurred, it tells you nothing about B occurred. But if events are disjoint, if A occurs, B can't occur. So are A and B independent or dependent if they're disjoint? They're dependent because you know that B did not occur if A occurs if they're disjoint. Does that make sense? Because you're like, oh, well, I know. And you think about that. If I tell you, oh, my brother had another boy, and you're like, well, did he have a girl? And you're like, I'm like, no, he had a boy. And you're like, well, you haven't told me if he had a girl. I'm like, well, him having a boy depends on him having a girl. They had one kid. You know, the answer to the question, you know, I answered your other question because it's dependent. That's got it. Good job, onliners. I don't think we have any more onliners online. Nate and Emma. If you have questions, Nate and Emma, feel free to ask. I'm going to log off. But we did a really good super review of probability with some of the harder questions. I don't want you guys to get blindsided for anyone watching the video right now. I don't want you to get blindsided on the test. We stayed till the very end of class time here. But like you have to know these things like this almost sometimes. Does that make sense? Like you have to be able to do these examples. Those questions I just did today separate the A's from the B's on this next test. So, like, do they really, I know they might be a little difficult now, but do you feel that there might be a trick to it that when you see it, it's just like, oh.
Like, it makes sense.
Great job, Nate. Yeah, it's, I think on the Quizlet, has anyone looked at the Quizlet? I've got a bunch of stuff on the Quizlet, especially with the randomness. See ya, Emma.